Welcome to Model Engineering for Beginners. This is part 10 and it's all about making a steam engine slide valve. A steam engine slide valve, whether it be full size or miniature, controls the admission and exhaust of the steam. And I'm going to machine a slide valve out of this piece of gunmetal. This is a piece of cast gunmetal. First thing to do is to use the linisher or belt sander to remove most of the sand scale, because sand scale on cast metal can blunt the tool. By removing this rough skin, it also makes the metal easier to mark out. I need to mark out a piece 1 1/4 inches long, and as you can see here, I'm doing it a 1/16 oversize. This will allow me to machine each end of the slide valve blank and get a very good surface finish when the valve blank is milled down to its finished dimension of 1 1/4 inches in length. I'm assuming that everyone watching this has never done anything like this before, so if you have, just forward on to the next section. This clip shows me using my very old bandsaw to cut the piece to length, and don't forget it's currently a 1/16 of an inch oversize. Usual health and safety disclaimer: when doing a job like this, always wear PPE, personal protective equipment, but you don't need any PPE for using a ruler to mark out the work. So after a quick look at the dimensions that I need, 1 1/4 by 3/4 of an inch, it's over now to the milling machine. Fitted to the milling machine is this face cutter. I've had this for quite a long while, and I use it when I need to remove a lot of metal at one go. As my milling machine is a mill drill of Taiwanese origin, it makes a bit of a row cutting with this, but it does the job and it gets rid of more metal quickly. And here it is in action. Most of the rattling you can hear is actually the cover at the top, and even though it's a fairly crappy machine and a very battered machine vise because it's done a lot of work, it still does what it needs to do. When you're doing a job like this, it's a really good idea not to rush it. Don't be frightened of the cutting tool, it's very nasty, but provided you keep your fingers out of the way, you shouldn't have a problem. The idea of using this tool is to make the block square, so now I have one known flat surface. And now that I have this one flat surface, it's time to turn the piece over in the machine vise. By using a suitable piece of packing that I also know is level, I can remove some metal from the other side, and we end up with two surfaces that are fully parallel. This clip shows me tapping the piece of gunmetal with a soft-faced hammer. This is just to make sure that the piece is held properly in the machine vise. You can tell by the sound, but it does take a bit of practice to hear it. As a general rule, if you're taking a deep cut, traverse slowly. If you're taking a shallow cut, you can traverse a little quicker. But please, not as quick as this. This video is speeded up just because the process is very slow. The speed that you can go at is really governed by the strength of the milling machine, but do be careful. If you break a tool, not a facing cutter like this, but an ordinary milling tool, it can be really bad. I once did that. The milling cutter snapped, and it whistled past my ear and embedded itself in the concrete wall of my workshop. No such events this time. Here's a finished block. What I'm doing here is rubbing the block up and down on a piece of 400 grade wet-to-dry sandpaper. This removes all the sharp edges. And when I check the dimensions with the ruler, I'm quite pleased. It's 3/4 of an inch by 1 1/4 inches long. Any proper engineers need to turn off immediately, because what I'm doing here is I'm laying the finished part on top of the drawing. As the drawing is 1:1, it's showing me that my piece is the right size. This has never bothered me. I've done it on most of the things that I've built when I've had a drawing that's 1:1. When building model aircraft, and I've built plenty of those, you put the plan down on a piece of board, and then you pin the pieces of balsa to the board and glue everything together, and finally remove the pins and remove the piece of aeroplane, and it's the right size. So unashamedly, I show you how to do this. What I need to do now is transfer some more dimensions from the drawing to the piece of metal. The position of the machine recess in the slide valve is critical and must match the cylinder exactly. If you're not sure about this and you want to have a second opinion, have a look at your cylinder ports. It's best to measure twice and mark out once, which is pretty much the same as measuring twice and cut once, but you're not cutting until you've marked it out. You will notice that on this drawing all the dimensions are in imperial, 11/16, 1 1/4 inches, ½ inch. Here in England for many years we've used a metric system, which makes a lot of things simpler. But I prefer the imperial system because that's the one I was taught at school. Before you can continue, you need to know what exactly half of 1 1/4 inches is. And if you're not comfortable with fractions, you could of course Google it. That would give you the answer. Or you could lay your ruler on the drawing. That would give you some rough idea. Another alternative is you can work out fractions in a really silly way. For instance, if you want to know what is half of 1 1/4, well, half of 1 is a half, and a half of a quarter is an eighth. When you add a half and an eighth together, that gives you 5/8. This video is a combination of another 2 videos that I did whilst I was rebuilding a Clarkson steam engine. I've added some more narrative to it, like this that I'm speaking at the moment. And from the other videos it became apparent that a lot of the viewers were clueless on fractions. To say that I was not very good at maths at school is an understatement. My final maths school report actually said, and this is not a joke, further critical comment would be futile. So hardly surprisingly, I left school without a qualification in maths. Once I started building steam engines though, I realised that I needed to sort of figure it out. So I figured the fractions out first. And then I discovered girls. No, this is not right. And then I discovered pi. But I don't mean pi, P-I-E, I mean P-I, 22/7. By using pi, I found that I could calculate where the holes needed to go in a circular steam cylinder cover. If only I'd been taught the practical applications at school, it may have been a different story. So that equates as lack of fundamental rudimentary knowledge can make it so that you never go near a subject that otherwise you would excel in. In this short tutorial about making a slide valve, I thought I would quickly go through some bits and pieces about fractions in a very simple way. Mathematicians, please turn off now, and engineers, go make a cup of tea. For instance, half of 3/4 is 3/8, and half of 3/8 is 3/16, and half of 3/16 is 3/32. So you will notice that the bottom number is always doubling for half the size. The top number remains the same. I'm really not being condescending or sarcastic on this section. It really is quite simple using fractions at this level. The finished dimension of this valve is 3/4 of an inch by 1 1/4 inches by 5/8 of an inch tall. If it's any larger than 5/8, the steam chest cover will not fit on, and that is not a good thing. A quick note about marking out when using gunmetal. Gunmetal is a very soft metal, and if you want to know more about the physical properties of gunmetal, I would suggest that you Google it. And when marking out on gunmetal, you need only the lightest of scribes across the piece. If your scribe marking lines are too deep, you'll only have to remove them on a piece of sandpaper. So here we have the centre mark, and I'm counting up the 8s. There they are, 5 of them at each side. It's very important to check that the slide valve recess corresponds with the cylinder. Here's the port face of the cylinder, and I'm just giving it a quick check with the ruler. It's not perfect, but it's within dimension. If the slide valve recess is too big, the engine can never work. In a steam engine of this type, the slide valve is the most important part. If this is not machined correctly, the steam engine will not work at all. If the piston fit is sloppy, the steam engine will not have much power. But if the slide valve does not admit and exhaust the steam properly, it just cannot work. The slide valve is now marked out for the cutting of the recess. But before I machine the recess, using a very small milling cutter, as the large face cutter is already fitted to the machine, I will use this to remove the surplus 1/8 of an inch. This will make the slide valve 5/8 of an inch deep from top to bottom, as you can see on the drawing here. Then it's over to the milling machine to remove this 1/8 of an inch that we don't need. I appreciate a lot of people who watch my videos are beginners, and I do tend to cater for beginners, because anyone who's an expert doesn't need to watch a video like this. You will notice on the work quite a large burr is building up as the face cutter goes back and forth. This burrs all the way around the edge, and before the next part, which is cutting the recess, you can either remove this burr with a file, a piece of sandpaper, or on a Linisher belt sander, which is the way I did it. So once the block's been deburred, the next job is to mill the recess in the slide valve. I'm using a much smaller milling cutter, as you can see here, and yes, I know it's held in a drill chuck. It's held in a very old, very stiff drill chuck that seems to be okay, it doesn't vibrate loose. I do have a Clarkson milling chuck, but it takes too long to mess about with the collets. And this is a very light duty milling job, so it's perfectly fine in this old tight chuck. You will notice that I start in the middle. Never start up against the line, because the first cut, if you're a little bit presumptuous with it, a little bit heavy-handed, this very small milling cutter is likely to wander all over the place and make a mess of the edge. So I'm starting in the middle. This old milling machine has got some longitudinal stops, and these are set to the maximum length of the slide valve's recess. I don't have any side-to-side stops, so I do this manually. I do actually like doing this part of the job, but you have to have a very delicate touch on the hand wheels and don't try and take too much metal off at one go. Back and forth and side to side, and then take the middle out and then start again in the middle, and eventually I get the depth that I require and I get a really nice looking slide valve. Obviously all of the time I spent as a child playing with an old Etch-a-Sketch that I used to have has finally come in useful. Here is the finished slide valve, and the recess is very neat and dimensionally accurate, which is what I really wanted it to be. The next job is to mark out the positions for the two cross slots at the other side of the valve, and then put it in the machine vise as you see here, and chow away with a milling cutter. Not as quick as this, I've speeded it up as you can see. In actual fact, this milling cutter is slightly smaller than is needed for the valve rod to pass through the slot, so once I've got it to finished size, I just take a little bit more off each side, which not only cleans up the edges of the slot, it makes for a perfect fit. It's a slack fit. Don't forget, slide valves must not be tight on any parts of their travel. And it's almost worth taking into consideration the fact that gunmetal expands slightly more than stainless steel when it's heated, as in when the engine's in steam. So if you get it just a little bit slack, it may tighten up. Cutting the cross slot is more or less the same as I've just described, and don't forget to make sure it's not a tight fit on the brass piece that the valve rod screws into. A nice easy fit's what we need here. A couple of thou clearance will be fine. The threaded brass piece just falls out under its own weight. I suppose you don't really need to do this next bit. I'm trimming it to shape, approximately to the plan, and I suppose this reduces some reciprocating weight, which is a good idea. The final part of the job is to clean up the piece of metal. I'm using some 400 wet dry sandpaper and a bit of oil. You don't really have to do this. It's hidden in the steam chest, but that is not the point. My father always taught me that if a job's worth doing, it's worth doing well. So this little bit of extra effort makes for a very nice looking component. The oil on the sandpaper just makes the sandpaper cut better. If you use it dry, then it gets a bit lumpy and it can actually scratch the component, but a bit of machine oil like this just gives you a better finish. Now when I put the valve over the drawing, as you can see, it's not 100% the same as the drawing, but it's only the outer shape. All the vital dimensions are very accurate. So there you have it, how to make a slide valve. Here it is, held up against the cylinder in the steam chest. Quite a lot of this video is taken from my How to Rebuild a Large Clarkson Vertical Steam Engine. I've added some things and taken some things away, but it's very similar. In this clip, I'm showing the newly made valve positioned in the steam chest and against the cylinder port face, just to show how it's going to be. This is from the Clarkson rebuild, and as you can see, the steam chest is not quite the right shape and needs a bit of work, but that's nothing to do with making a slide valve. So thanks for watching, and I hope you found it useful.